Just completed question number 28. Let's go to question number 29. 29, this should be very familiar to you. You have seen this on previous quizzes and I think also on homework. A contractor designs a rectangular pool with a 3-foot walkway around it. In class, look at the question the diagram. You already see the 3 feet is marked. We know this is 3 feet wide this way. This is also 3 feet wide. And this is also 3 feet wide. Given the expressions for the total width and length of the pool and walkway together, write an expression for the width and length of the pool only. All we got to do is figure out what are the dimensions of just the pool. Well, let's assume that this is width. I'm going to just label that as W. That's width and this is length. You could switch those around as well. It makes no difference. The width of the pool, well, we know the width of the pool and the walkway is 2x. And we have to subtract 3 feet from the top to get down to this corner. And we have to subtract 3 feet from the bottom to get to this corner, so that all we're looking at is the width of the pool only. So we take 3 feet off the top and 3 feet off the bottom. That means we're taking a total of 3 feet and 3 feet, and that makes our answer equal to 2x minus 6. So the width of the pool only is 2x minus 6. The length is the same thing. The length of the pool and the walkway is 3x plus 11. This is a 3-foot walkway all the way around. That means we're going to cut 3 feet off of here. Put a little mark there. And we're going to cut 3 feet off of here. So we're going to cut 3 feet off of both sides of the 3x plus 11 to get down to the pool width. So we're going to get rid of 3 feet and get rid of another 3 feet of walkway. We can combine these terms together and we're going to end up with 3x plus, what is that? 11 minus 6 is 5. So we've got 3x plus 5. There are our dimensions of the pool only. Letter C is asking, what is the expression for the area of the pool only? Well, area is equal to base times height, or we can also say length times width. And in this case, our length is 3x plus 5, and our width is 2x minus 6. So we have an expression 3x plus 5 times 2x minus 6. Now you can spend the time and distribute and come up with a standard form quadratic, but it doesn't ask you that. It just asks you for the expression. We can just leave it in this form. Question number 30 is just a repeat of that, just a little different numbers, a little different story. A photo has a 4-inch frame around its entire border. Okay, that means, class, this is 4 inches all the way around. I'm going to try to write in there 4 and a 4 and a 4 and a 4. 4-inch frame. Given the expressions for the total width and height of the photo and frame together, write an expression for the width and length of the photo only. So let's go ahead and call this length. Let's call this width. So width of the pool only, we start off with 3x plus 6, which is the width of the frame and the photo. We're going to have to get rid of 4 inches from the top and 4 inches from the bottom. So our final expression is 3x. 6 minus 4 is 2, minus 4 is negative 2. So the width of the photo is 3x minus 2. And then the length here is, and again, you could just name this width and this length. It makes no difference. In our case, the length is 3x plus 10. And we're going to subtract out 4 inches from, look at our length here. We've got to get rid of 4 inches on the right side and 4 inches on the left side. So 3x plus 10 minus 4 minus 4. And we end up with 3x. 10 minus 4 is 6, minus 4 is 2, so 3x plus 2. Final question, what is the expression for the area of the pool only? Remember, area equals base times height. Or we could also say, again, length times width. I should just write it as length times width because that matches our problem. Length times width. So all we're going to write down is the length of the pool is 3x plus 2, and the width of the pool is 3x, sorry, not pool, I'm thinking swimming pool. The length and width of the photo, just a photo with a frame, sorry about that, I got so used to the story about the pool, I just kept thinking swimming pools. 3x plus 2, and the width is 3x minus 2, and there is our expression for the area of the pool. I think we have enough time on this video to go to the next set of questions. Let's take a look. For questions 31 through 34, describe the shift or change that each parameter has on the graph of a parabola. First question is, what does the sine of the parameter A do to the parabola? Okay, so a complete sentence for this would be something like this. The sine of A determines the direction of the parabola. Okay, a positive A opens up, a negative A opens down. So here's our answer. The sine of A determines the direction, or the direction of the parabola. A positive A opens up, a negative A opens down. Number 32. What? Describe the shift or change that each parameter has in the graph. Okay, so when the parameter A, or absolute value of A, I don't like how this is asked, class. So basically what it's saying is, what happens with the parabola when the absolute value of A is greater than 1, or the absolute value is between 0 and 1? Okay, so I'm going to put the absolute value of A determines shape, the shape. Determines the shape. So sine of A determines direction, the absolute value of A determines shape. And then we can put when absolute value of A is, that looks like a curve, let's fix that. When the absolute value of A is greater than 1, the parabola stretches. When the absolute value of A, I'm just going to put the absolute value of A, well, I better not put less than 1 because it doesn't count 0. When the absolute value of A is between 0 and 1, that'd be more correct, the parabola, try to fit this all in one line, the parabola compresses. Okay, so there's our two effects of A. Sine of A determines direction of the parabola. The absolute value of A determines the shape of the parabola. Look at parameter H. What does H do? The parameter H, I'll just say the H value shifts the parabola left and right, or we're going to say horizontally. Horizontally. Horizontal means we're going left and right. A positive Let's describe what we know about this. A positive h shifts right. A negative h shifts left. Remember, negative h means we're moving negative on the x-axis, so we go to the left. A positive h means we're moving right on the x-axis, which means we're shifting, positive on the x-axis means we're shifting to the right. Okay, and last one, the parameter k. The k value, this is going to be almost the same answer as above. The k value, and I'm writing very messy to get through this for you guys, but if you're listening to me talking, you're going to be able to know what I wrote. The k value shifts the parabola vertically. K value shifts the parabola up and down. A positive k shifts up. That means we're going positive on the y-axis. A negative k shifts down. So there's a summary of A, H, and K. A, sine of A determines the direction, opening up or opening down. Absolute value of A determines the shape. A big absolute value of A means it stretches. A small absolute value of A means the parabola compresses. The H value shifts the parabola horizontally. And the K value shifts the parabola vertically. All right, we will go to the next video to answer questions 35 and 36.